Today I am going to solve one fluid mechanics numerical problem on viscosity. Here is the numerical problem. A plate having a size of 100 mm into 100 mm is pulled with a velocity of 0.05 meter per second over a fixed plate at a distance of 0.25 mm. Find one, the force, and second, the power required to maintain this velocity if the fluid has a dynamic viscosity mu is equal to 1 poise. So this is the problem. So upper plate is moving and bottom plate is fixed. So plate size is already given, that is 100 mm into 100 mm, and upper plate is moving a velocity with that is 0.05 meter per second, and distance between two plate is 0.25 mm, that is given. We have to find out the force and power required to maintain this velocity, and dynamic viscosity of the fluid is given, that is 1 poise. So here is the data is given. So size of the plate 100 mm into 100 mm, so that is 0.1 meter into 0.1 meter. The velocity of the plate is given, u is equal to 0.05 meter per second. Distance between the plate dy, that is nothing but 0.25 mm. So if we convert mm to meter, so that is 0.25 into 10 to the power minus 3 meter, so that is 2.5 into 10 to the power minus 4 meter. Dynamic viscosity is given, mu is 1 poise, so that is 1 into 10 to the power minus 1 Newton second per meter square. So that is, these are the all data are given. Now first we have to calculate velocity gradient. Velocity gradient, we know du by dy is the change in velocity per unit distance between the plates. So du by dy is nothing but 0.05 meter per second by dy 2.5 into 10 to the power minus 4 meter. So du by dy is nothing but if we do the calculation we will get 200 second inverse. So unit of that velocity gradient is second inverse. Now first calculate the shear stress. So tau, that we know, tau is equal to mu du by dy. So here we know that mu, so mu is 1 into 10 to the power minus 1 Newton second per meter square, and velocity gradient we calculated already, so that is 200 second inverse. So now after doing the calculation we will get tau is nothing but 20 Newton per meter square. Now the force is then, okay, what will be the force? So we know that tau is that shear force by applied area, shear force by area. So force will be tau into A. So now we know the tau already here, the tau is 20 Newton per meter square, and area, that is we know 0.1 meter into 0.1 meter. So that is, now if we do the calculation we will get that force is 0.2 Newton. That is the one part of the question. So part 1 question answer is 0.2 Newton. Then we have to do the power calculation. So power P is the product of the force into the velocity. So P is nothing but force into velocity. So we already know the force is 0.2 Newton, and velocity we know from this given data, so that is 0.05 meter per second. So if we do the calculation, so power will be 0.01 watt. So now here two things we need to calculate, already we did that. So that is force required to maintain velocity F is 0.2 Newton, and power required to maintain velocity, that is P is equal to 0.01 watt. That's it. Thank you.